In this example, we're considering the position of a spacecraft and what happens to its motion. We're given a position vector for it moving through space, which I have just underlined. We're asked to find the velocity and acceleration at any time t. So we know if we have position, we differentiate that once, that gives velocity. We differentiate that again, that gives acceleration. So I've written down the position vector. I'm going to differentiate that with respect to time, t. That will give me velocity. Derivative of 2t minus 1 is 2. Derivative of t squared is 2t. Derivative of t cubed is 3t squared. And I've written the I, j and k components. Differentiate the velocity with respect to time will give me acceleration. When I differentiate the two, I get 0. 0I, which is gone. So derivative of 2t is 2. Derivative of 3t squared is 6t. So I've got 2j plus 6tk. I've now got my velocity and acceleration at any time t. Now, it also asks me in part P the initial speed, time is equal to 0, and the speed after 2 seconds, t equals 2. Now remember, we have a velocity at the moment, we have not got speed. So now let's go and consider this part of the question. For time equals 0, substituting that into the velocity formula, I get 2I plus 2 times 0j plus 3 times 0 squared k. So the parts with the zeros disappear. I'm just left with 2I. So what I have to do is find the magnitude of that vector, because it is the velocity vector when time is equal to 0, to give me speed. So that speed is equal to the square root of 2 squared. The square root of 4, which is 2. So it is 2 meters per second. When time is 2, I can substitute into the velocity formula as I have done here, and I've got 2I plus 4j plus 12k. To find the speed, I have the square root of, I have 2I, so 2 squared, plus the 4j, 4 squared, plus the 12k, plus 12 squared. Tidying that up, that will give me 2 root 41 meters per second. Part C of the question asks me to find the magnitude of the acceleration. In part A, we found the formula for acceleration, 2j plus 6tk. So finding the magnitude of that is just like when we found speed. We have 2 squared plus 6t all squared, which gives me 2 squared is 4, 6t all squared is 36t squared. That is 4 times 1 plus 9t squared. Using our third laws, the square root of 4 is 2, so I've got 2 root 1 plus 9t squared. I now have a general formula for acceleration in meters per second squared.